So you're building the next big thing, right? And you're grabbing these amazing, powerful AI models off the internet to speed things up. But have you ever stopped to think, what if that incredible tool is actually a Trojan horse? That's what we're talking about today, the seriously sneaky and growing threat of malicious AI models.
Wow, this quote just nails it, doesn't it? It's a cat and mouse game. This isn't some problem you can just patch and forget about. It is a full-on battleground. The second we build a wall, they're already digging a tunnel. It's a constant arms race, and believe me, the bad guys are getting super creative.
All right, here's the plan. First, we'll figure out what these things even are. Then, how they sneak in and what kind of chaos they can cause. We'll also cover why they're so good at hiding and, of course, what you can do to fight back. Let's jump right in.
Okay, so first things first. When I say malicious model, what does that actually mean? Let's break it down.
Yeah, the keywords here are embedded and designed. This isn't some bug or an oopsie. We're talking about an AI model that's been deliberately turned into a weapon. It's engineered from the ground up to attack your system from the inside the second you plug it into your code.
Okay, so if these things are so dangerous, how in the world are they getting into our systems? Let's take a look at the attacker's playbook. So attackers pretty much have three favorite ways to get in. You've got the most common one, sneaking into big online model hubs like Hugging Face. Then there's compromising the very tools you use to build your software. And the third one, it's a bit more techy, but it's a huge deal. They exploit the way the models themselves are packaged.
And this is where it gets really clever, because it's not just about code, it's about psychology. Attackers will go on a platform like Hugging Face and create a fake profile that looks exactly like it belongs to Meta or Visa or even SpaceX. They're banking on the fact that a busy developer will see that trusted logo, think, oh cool, a model from SpaceX, and download it without thinking twice. They're not just hacking systems, they're hacking our trust.
All right, let's talk about that third weak spot, serialization. What is that? Well, you can think of it like this. It's how you squish a big, complicated AI model down into a single manageable file so you can store it or send it around. Kind of like vacuum sealing a giant puffy jacket. The problem? Some of the bags they use for this are, well, really easy to poke holes in. They're just not safe.
And the poster child for this problem is a format called Pickle. If you're in the Python world, you've definitely seen it. It's everywhere. But here's the terrifying part. The Pickle file isn't just data. It can literally run code. That means the moment you load that model file, boom, you could be executing a hidden attack. And check out this new trick they've come up with, called the Nullify AI attack. This is brilliant in a scary way. The attacker uploads a Pickle file that's intentionally broken. The security scanner on the platform tries to check it, but it chokes. It can't read it. So what does it do? It just gives up and lets it through. The file sits there, waiting for some poor developer to download it. The attacker is literally weaponizing the failure of our security tools against us.
Okay, so the bad guy is in. The malicious model is downloaded and running in your application. So what? What's the actual damage they can do? Let's get into the payloads.
First up, the big one, arbitrary code execution. This is basically the worst-case scenario. The model acts like a beachhead. The second it's loaded, it runs code that can hand over the keys to the kingdom. We're talking full control of the machine. They can steal your data, your intellectual property, anything, or even use your servers to launch attacks on someone else.
Then there's the super sneaky stuff, like data exfiltration. Imagine you've got a chatbot that's generating text. It seems totally normal, but what you don't know is that it's been secretly programmed to hide your company's private data, like user credentials, inside its perfectly normal-looking sentences. It's basically a spy, smuggling your secrets out the front door right under your nose.
Another angle is model poisoning. Here, the goal isn't to steal your stuff, it's to break the model itself. Think about an AI that's supposed to detect malware. The attacker could poison its training data so that it learns that a dangerous virus is actually a safe, friendly file. It completely undermines the whole point of having the model in the first place.
And this one is straight out of a spy movie. Backdoor functionality. The model acts like a sleeper agent. It works perfectly, day in and day out, maybe for months. But it's waiting for a secret signal, a specific word, or a certain type of image. When it gets that trigger, wham! It activates a hidden backdoor and does something nasty, like letting an attacker bypass all your security.
Okay, this is all pretty terrifying, right? And you're probably wondering, wait a minute, don't we have security tools for this stuff? Why aren't they just catching these things? Well, the short answer is, our traditional tools are basically blind to this threat. Think about something like a software bill of materials, an SBOM. It's great at listing ingredients, but to an SBOM, an AI model is just one big black box. It has no idea what's inside. Your antivirus is looking for known bad guys, but these models are designed to look like the good guys. And the biggest problem? None of these tools can see the training data, which is like trying to solve a crime without ever looking at the evidence.
So yeah, it's a tricky, sneaky problem, but it's not hopeless. The question is, how do we fight back? How do we build a defense that can actually stand up to this?
First, let's get one thing straight. There is no magic bullet here. You can't just buy a product and call it a day. A real defense has to be woven into everything you do with AI. It starts with secure design, way before you write any code. It means testing for weird behaviors, not just accuracy. And it means being just as careful about where you get your models as you are about any other piece of software. It's a whole new way of thinking.
So, let's get practical. What can you do for your supply chain? Number 1, know your sources. Actually investigate who's providing the model. Number 2, ditch the risky formats. Use things like safe tensors instead of Pickle. Why? Because they're built to be safe. They can only hold data, not sneaky code. And third, use cryptographic checks, things like hashes and digital signatures, to make absolutely sure the file you're using is the one you think you're using.
And there's this really cool idea gaining traction called an AI bomb, an AI bill of materials. The best way to think about it is like a nutrition label on food. It tells you all the ingredients. What data was it trained on? Where did it come from? What are its known allergies or limitations? This kind of transparency is going to be absolutely crucial if we're going to trust these systems.
At the end of the day, it's all about balance. This is a team sport. You can have the best supply chain security in the world, but if you're not watching what the model does once it's live, you've got a massive blind spot. And if your developers don't know what to look for, they could accidentally leave the front door wide open. Every single one of these pieces has to work together.
So as we all rush to build the future with AI, we just have to be smarter. We have to be more skeptical. The next time you're about to download some amazing new model, just pause for a second. Ask yourself, do I really, truly know what's in this file? Is this model going to be my trusted partner, or is it a spy, just waiting for the right moment to strike?